Hey there! In this video, we're going to be looking at resistance, which was requested by Sonia Fredericks that wrote, "Can sir please do resistance?" Now without further ado, let's dive into the video. Welcome to Rise Up Namibia. My name is Metyanata, aka the resistor of bear and the lover of good, #dark and lovely _ walk by faith and not by sight. So, what is resistance? Resistance is basically the ability of an object to resist the flow of current. Okay? Now, before we look at the calculating side or calculations regarding resistance, I want us to quickly have an overview. Okay? Now, there are certain factors that affect resistance. Now, these factors affect resistance in regards to the conductor. Okay? Or a conductor. Now, in this example, to illustrate these factors, we are going to be using wire as a conductor. Okay? Now let's take a look at the first factor, which is the wire length. Now, how does the wire length affect resistance? The wire length affects resistance in a way that resistance is directly proportional to the wire length. What does this mean? This simply means that the longer the wire, the higher the resistance. Let's take a look at an example. Say for example, you have a wire over here that is 2 meters long. Now for a charge to pass through that wire, work is done. Okay? So meaning the charge does work to go through that or to flow through that wire. Now think of it this way. If you have another wire which is longer, say for example it's 4 meters long. Now for that same exact charge to flow through the longer wire, it needs to do double the work it's doing in the shorter wire. Okay? So hence, the longer the wire, the more the resistance. The shorter the wire, the smaller the resistance. Okay? Let's look at factor number 2. We have the cross-sectional area of a wire. How does that affect the resistance? Resistance of a wire is inversely proportional to the wire cross-sectional area. This simply means the bigger the cross-sectional area of a wire, the lower the resistance. Let's take a look at the wire that we just used. Now when we talk about cross-sectional area, we simply mean the thickness of the wire, or in other words, as we call it in mathematics, the diameter. Okay? So for example, this wire has a diameter of 3 centimeters. And then we have the same exact wire, but with a thicker diameter or with a thicker cross-sectional area, which is 6 centimeters. Now, in comparison, these two wires, which one do you think will have more resistance? The one with a smaller cross-sectional area, because it's inversely proportional, meaning when the cross-sectional is small, then the resistance is a lot. But when the cross-sectional is larger, the resistance goes down. Why is it so? Because basically if you look at a thin wire, even when it comes to the flow of charges or current, there is no a lot of space, okay? But the more thicker the wire, the more there is free or space, more space for the charges to flow compared to when it's having a smaller cross-sectional area, okay? Now let's look at Ohm's Law. Now before we check Ohm's Law, there's actually a third factor that I forgot there, which is temperature. Now temperature is directly proportional to resistance, meaning the more the temperature rises, the more resistance we get, okay? Then the lesser the temperature drops, then the resistance also drops. So what does Ohm's Law state? Ohm's Law states that the current through a metallic conductor at constant temperature is directly proportional to the potential difference across its ends. Okay? Now with that said, let's look at this formula. Since we are talking about resistance. So we have R equals to V over I. What does this mean? The R stands for resistance, which is measured in ohms, and the V stands for potential difference, which is measured in volts, and then the I stands for current, which is measured in amps or ampere. Now remember, I think the reason we use I for current is because the C, capital C, is already used for coulombs. Remember the unit of charge is coulombs. So I think the capital letter, if I remember correctly, the capital letter C is already used there. So I think to prevent confusion, they used capital letter I. So wherever you see a capital letter I, it means current. Okay? So let's look into examples. So here we have the potential difference across a lamp is 10 volts and the current through it is 1 amp. Calculate the resistance of the lamp. Now when you bring out your formula, you want to check through your statement again. What are you asked to calculate? You're asked to calculate the resistance. And the R is already the subject of the formula, which means R is resistance. So you just check your V and your I. Are you given potential difference and current already? When you reread into your statement, yes, we have a potential difference of 10 volts and we have a current of 1 ampere. So we substitute those figures into the formula and we get 10 divided by 1. So what is 10 divided by 1? That will be 10. 10 what? Because we are calculating resistance, it will be 10 ohms. Okay? And that's your final answer. Let's take a look at another example. Now here you are asked to calculate the potential difference in a given circuit if the current is 0.5 amps and the resistance is 2 ohms. Now again, when you bring out your formula, you always want to check or reread your statement. Sometimes you need to reread to understand what you are asked. So ask yourself, what are you asked to calculate? You're asked to calculate the potential difference. Now in your formula, which one is the potential difference? Potential difference is the V. So meaning this V is the potential difference. So this simply means that you need to rearrange this formula and make V the subject of the formula. So how do we do that? We can do that by multiplying I on both sides, and then it will cancel out this denominator. And then you are left with V equals to I multiplied by R. So let me just flip it and rewrite it down here. Now if you don't know how to change or to make a certain letter subject of the formula, I'll leave a link down below in the description that you can follow for you to check another video on how to do it. Or some people also use the triangle method. So if you know the triangle method better, I recommend you use it. Okay? So now you know that your potential difference equals to the current multiplied by the resistance. Now ask yourself, are you given current and resistance? Yes, in your statement we have a current of 0.5 amps, then we have a resistance of 2 ohms. So you substitute the 2 into the formula, and then 0.5 multiplied by 2 will give us a positive 1. Now positive 1 what? Since we are calculating for the potential difference, it will be volts. So it will be 1 volt. Okay? And that's your final answer. Let's take a look at another example. Now this example states a potential difference across a 24 ohm resistor is 12 volts. What is the current through the resistor? Again, when you bring out your formula, check in your statement, what are you asked to calculate? You're asked to calculate the current through the resistor. Now, which one is your current in the formula? Current, like I told you earlier, current is always the capital letter I. So the capital letter I is down here. Now, if you use the triangle method, Then you can use the triangle method to rearrange and find the formula. But for me, I make the I subject of the formula by getting rid of the fraction first, which is by multiplying both sides by I. Then it will cancel out on the right hand side. I'll be left with V equals to R multiplied by I. But since I want to have I alone on one side, I'll divide both sides again by R, which will cancel out on the left hand side, and I'll be left with I equals to V divided by R. Okay? So basically you should just know how to make a certain letter subject of the formula. Then you'll have current is equals to potential difference divided by the resistance. Now ask yourself again, when you check in your statement, are you given potential difference and a resistance? Yes, we have a potential difference of 12 volts and we have a resistance of 24 ohms. So you substitute the two into the formula, then you'll have 12 divided by 24, which will be 0.5. Now since we are calculating current, 0.5 watt, it will be 0.5 amps. Okay? That's your final answer. So in the next video, I might as well just give you an example of a drawing, because sometimes they don't necessarily give you a straightforward question like this. They might ask you to draw a circuit or give you a circuit drawing. So I think I might give you one in the next video where we will be talking about total resistance. Okay? So thank you very much for watching this video. Please do like, subscribe, turn on the notification button to be the first to see the next upload. Share with friends, family, and classmates. And remember, together we rise to higher heights, apart we all stay behind. Cheers.